So I'm going to show you some uh, examples of ready-mades, some examples of how they can be transformed into uh, an ordering system, and specific examples of the type of drawing that you'll be producing. And then we'll conclude with some images of a handful of images of plans and sections of the, just indicating the kind of degree of resolution that you should expect. So what is this concept of the ready-made? So you've seen this image before last semester. This would be an example of an object that one could take as a ready-made for an architectural order. In this case, it's a kind of stacked system of volumes in a kind of a pinwheel pattern. Each level is rotated 90 degrees from the one below it. The end result is a simple monolithic form. That, as a totality, could be seen as a ready-made. In other words, I can take this object and use it very directly to inform building organization and a material logic, whether that's wood or not. You can see that operating here in Paul Rudolph's architecture building at Yale. So here there's a kind of, you can see that same sort of log cabin logic of the horizontal elements and the vertical ones being stacked. Zago's drawing is an example of another kind of ready-made. I mean, ready-made can be whatever you want it to be, but in this case we'll be giving you this set, so Zago's will be one of them. It's a particular type of drawing that this is part of a longer research he's been doing on drawing. These are cut strips from different packages, literally cardboard packaging, and that have been woven together to create a kind of interference pattern. So there's a strategy of weaving, technique of weaving, and the result of a kind of pixelated effect. There are constraints. All the strips are the same. The horizontal strips are wider than the vertical strips, but the horizontal strips are all the same width. Vertical strips are all the same width. Right? So there is an order to it. You saw this image a couple of weeks ago, Andy Warhol's ink blot test drawings. In this case, the logic of the ready-made is the vertical axis as an axis of mirroring. In other words, the ink blot test is a vertical fold, and the resulting pattern is loosely symmetrical. It's symmetrical in general, but because of the idiosyncrasies of the material, the paper and the ink, you have very minute variations between one side and the other, between the one half of the page, the left half of the page, and the right half of the page. You've also seen these redrawing of plans of castles. We talked about this with figure ground poche, and I'll show you an example a little bit later of a student project that took this into, made use of this as a ready-made. The Cordoba Mosque, right, the primary attributes of this ready-made being the organization of a simple volume on a grid. And in fact, it's more complex than a grid because there's a vertical banding. Right, so the grid is not just the grid of columns, it is a non-uniform grid where the horizontal and vertical are different dimensions, and therefore creates a kind of grain. There is a longitudinal grain to the plan, except in the garden at the bottom of the drawing in both sides, in which the grain stops and the space is subdivided into these three gardens. So mosque plan as a kind of ready-made. Circular labyrinth So centralized figure, concentric, starting with concentric rings, which are then broken into a complex pathway. Jasper John's paintings of targets. In a very straightforward way, the ready-made here is concentric alternating bands. I'm talking about the blue and the yellow. The plan for the Pacific Hotel, Kikutake's plan, which is a, let's see, 1, 2, 3, 4, 5, 6, roughly hexagonal, but not regular polygon. One of the sides is longer than the others, which is then rotated. The inner core is rotated roughly 45 degrees from the outer core, the outer profile. Ledoux's show cemetery, also centralized figure, radial geometry, diagonally symmetrical. Trogni's Danteum, and in this project, there's a couple of Trogni examples. In this one, it's a figure, the primary figure of the plan is a golden section, so you can see the square on the right. And that golden section is then slipped and repeated to form the stair and pathway at the bottom. Adolf Loos's example here is the Villa Müller, but any number of his houses that make use of what he called the Raum plan, space plan, literally, in which the primary characteristic is sectionally interlocking spaces. In other words, spaces that are staggered sectionally so that you move vertically between them at 1/2 story at a time. Sculpture from Louise Nevelson showing another approach which you could take is a kind of cellular system filled by variants. In other words, the cellular system is loosely based on a grid, although as you can see it's not quite precise grid. And the container then is used to array a series of heterogeneous objects within it. Mel Kendrick's work I think is particularly useful for some of you. In this case, if you look carefully at this, you see what's going on is the voids taken out of the bottom half of the sculpture are used as an assemblage in the top half. Right? So the sum of the top and the bottom equals the original block from which it was taken. And some of you are dealing with a sectional condition where this principle might be quite useful. And then more precisely, the elements subtracted are roughly conical in nature. Serlio's theoretical design for a theoretical project for a house, and this is an example of one of the canonical ready-mades, which is the 9-square grid. So as an ordering system, this is extremely common, and the ready-made is essentially an instance of a 9-square grid design. So you can see the 4 corner rooms take up 4 of the grid cells. The outdoor spaces are front and back outdoor spaces take up the middle 2 grid cells, etc. And then he introduces variation within the 4 corners with different room types. But all of this conforming to a 9-square gridded plan. I'll show you an example of this at work. Sterling's Leicester Engineering Building, an example of what you could call a kind of a cross-grain, diagonal grain logic. In other words, a primary figure which is then subdivided on a 45-degree cross-grain grid. Frank Lloyd Wright's Price Tower, This is a kind of a pinwheel plan. So you can see it's centralized, but it uses a pinwheel logic. Another pinwheel plan, Schindler's King's Road House. You can see revolving around that central fireplace in the middle and rotating around that point. So both building mass and garden rotate around that central axis. All right, so what do you do with those? Well, the first thing you have to abstract the geometry from the. You have to abstract the fundamental geometric relationships within it and the kind of potential. So if for the Jussieu library, OMA took the ready-made of the floor slab and column structure, in a sense Corbusier's Maison Domino, expanded to the scale of a large building. That was, in a sense, the ready-made that launches this project. That is then split and made into ramps as if it were a parking garage. That then produces in the end the building in which all floors are sloped, and there's a sequence ramping up from bottom to top. So there are flat areas, there are sloped areas. So you can see very clearly that this was from this model, that there was a ready-made of a standard floor slab and column domino structure that then is distorted and manipulated to do the work that they wanted it to do. And in this case, columns remain and floor slabs become the primary place of intervention. From student work, this is the ready-made is a very simple cube with a void in the middle, and then the primary operation is a slicing or cutting, and then a shearing to create variation. This project is, in a sense, the diagram on the far left could be considered to be the ready-made, a figure that has any number of potentials. The pochette in the original is treated in the middle diagram as circulation space. And then on the far right, some rooms are treated as voids to below and to above, and others as floor. But it all comes back to that diagram on the left. Eisenman, of course, starting with the generic, this is a 9-square cube, so it's a 27-square problem. But each face of the cube is a 9-square problem. And that ready-made is very present, right? He encodes it in the red. We're interpreting the red to be the initial ready-made, and then this translation, duplication and translation of the pink figure. And then in its various other developments where that grid, the red and the pink grid, are almost entirely gone, but the ready-made is still operative as the generator. Now a lot of this comes back to this we looked at last semester, Witkover's plans, Palladian villas, where there is a kind of a ready-made, and Witkover defines it at the bottom right, which is the generic pattern that all of these villa plans conform to. So you get a sense of the kind of variations within that one figure. So a couple of examples from 2 years ago. I gave students a similar assignment, and so here you have on the left the Mies National Gallery in Berlin, spatial analysis of the form and the tectonic logic of that building. And then the mapping of that and the redrawing of it within the space of the building that this individual was using as in this case it was an existing building I had asked them to deal with. But you can see on the right the boundaries of what we're calling our module, and then the subdivision of that module using the regulating geometry derived from the initial source at the left. Likewise, Serlio's 9-square reinterpreted as a 3-dimensional matrix. So the 9-square still persists in the drawing on the right, but it is now no longer used just as a plan, but as a fully 3-dimensional series of spatial intersections. And this student was more interested in the irregular rooms in the original plan. So you can see the 9-square is being modified. In this project, the author took Kahn's castle plans as a starting point and filled the volume of her project with 2 versions of the original plan, the one above. The one at the bottom is pretty much an extrusion of one of the plans, except you can see it's not a strict extrusion. She's gone through a lot of trouble to modulate that extrusion with openings and various discontinuities on the vertical axis, on the z-axis. The drawing above is simply an inverse, a negative of the figure-ground relationship of the original. And I think these are really exemplary drawings of taking a ready-made and appropriating it for your own purposes. The final 2 drawings on the right couldn't be farther from the original building. I mean, it's a totally different building, but obviously very intentional with the use of the ready-made, very direct. So in your case, what we're asking you to do is start by drawing the bounding cube of your module. Then introducing the most generic form of the ready-made. In this case, I'm using the 9-square grid just as the simplest possible example. In this case, laid out the 9-square grid as a starting point for the plan organization, the floor, the horizontal surface. The most straightforward operation that I'm showing you here is just a simple extrusion of the 9-square up vertically throughout the extents of the building, right? Because of course, again, the problem here is how do you regulate the volume of the whole module using this ready-made logic? So in this case, a simple extrusion. And then inhabiting that with forms that are offset from that 9-square. Again, this is a trivial example. Or you could take this same volume, same 9-square, a partial extrusion up a third of the way, right, so that the elevation is also treated as a 9-square. And then, this is a little hard to see, a rotation in 90 degrees so that the extrusion is now horizontal. So in this case, the 9-square is treated both as a plan figure and as an elevation figure. This is, again, a very trivial, uninteresting example, but just to give you a sense of the sequence of what you're being asked to do, which is define the volume of the module, subdivide it, modulate that subdivision, and then inhabit it. Again, to be absolutely clear, the primary volume that's being shown here, the main starting volume, is a single module. So if this were a single site project, this module that you're looking at, meaning this one, is only a part of your building. Right? So we're really focusing on the individual part here. Okay, so examples of the kinds of drawings that you might expect to do. I included this actually, this is part of the ready-made diagram, but this is a particularly nice drawing by Herbert Bayer. This is Bauhaus era. Really nice use of color and transparency to describe this kind of complex matrix of space in which everything from lighting fixtures to furniture to floor pattern are absorbed into that geometric logic. But mainly, you're being asked to do a plan in a section perspective. So a plan like this is from Stirling is well within your abilities to produce now. It is meaning you know enough about your project to be able to produce a plan like this. One thing to note is the plan is very specific programmatically. In other words, stairs indicate circulation. Shelving, recessed shelving indicates storage. Books, in this case, it's a library, this project. And, restrooms indicate, fixtures indicate restrooms. Everything is, the program is implicit in the objects that are being shown. And this is part of the challenge of this stage of the work, is through a single module start to encode the program as an object. Tyranni's Casa del Fascio, redrawn for a studio that Eisenman was teaching, where the students studied these buildings very meticulously. Again, this you can see just through the use of tile and details like doors, how the program becomes legible. This, I also recommend, in both of these cases, there's no poché in the plan. In other words, the sectional material that's being cut in the plan, the columns, the walls, are left white with a heavier black line around them, and it makes it much more legible. Mireles, a real master, kind of a master of these types of drawings, line drawings, particularly plans. Ton of information here, dashed lines representing on the left mezzanines overhead, upper level plan on the right, indicating very clearly, even though the forms are kind of enigmatic, the stairs are so carefully drawn that one can immediately see what's above, what's below. You can see the two mezzanines interacting, one slipping beneath the other. I mean, they're really masterful drawings. Another example. Right, so in this case, there's some details that he's pulling out as interior elevations and small kind of moments in section off the edges of the plan. But have a close look at these drawings. These are really masterful line drawings. Then for the sectional perspective, Stirling is, again, quite expert in these types of drawings. Note the place where he's chosen to cut the section. We have two ramps on the right. We have a quite elaborate skylight lighting system on the left. There's a significance to the place where the section is being cut. And again, you can do, you should expect to have this much detail by the end. The end meaning 4 weeks from now. Maybe a little simpler example, the Clore Gallery sections, again, cut through really interesting sections, right? Cut through front door, primary stair, public stair going up, this large gallery, skylit gallery above. Atelier Bauau, dealing mainly with residential scaled work, so it's a little smaller than what we'd be dealing with, so this is maybe more detail than you would expect to have, but there's a sense that, as yours should, and as Stirling's did in the previous example, that this piece stands in for the whole. In other words, we can understand most of the building from this one drawing, because the rest is fairly generic, right? It's simple, generic galleries. Likewise here, we don't need all of the information about the house to have a sense of what this project is. It conveys the material, it conveys a primary spatial logic, which is this stair with this triple height space in the middle, rooms spiraling around it. It's a kind of a round plan, right? You can see how the rooms are staggered. The floors are staggered. You go up a half floor each time. So that's directly from Adolf Loos. And Nate showed you this last semester in ProPrac 2. This is the house that they did with water storage in the walls. And again, this is domestic scale, but really you could expect to aim for this degree of detail in your section perspective. The idea of the section perspective is it stands in for much more than it is. In other words, I can imagine everything behind us, behind the picture plane, to the rear, without having to show it. In other words, it is a drawing in which this fragment speaks to the whole building. So you can convey a lot about the project and about the project's intentions through this one simple drawing.